In this lesson, I'm going to show you some practical applications of Boolean operations. Now, earlier I've explained to you that for ASCII characters, you know whether or not a character is uppercase or lowercase based on the third bit. Let's review that briefly. So here you can see that for the uppercase letters, the third bit is set to 0, and for lowercase letters, the third bit is set to 1. Now let's imagine you were writing a program that had the purpose to determine whether or not a character was uppercase or lowercase. How can you do that? The answer is obviously by looking at the third bit, but how can you do that from inside of a program? The answer is you use something called a bit mask. And the way a bit mask works is you set the bits that you want to check to 1 and everything else to 0, like this. Now here you see that what I've done is I've set the third bit to 1 because that's the bit I want to check, and every other bit is set to 0. The next thing you do is you take this is called your bit mask, and you apply it to what you want to test using the AND operator that you learned about in the previous lesson. Here's how it works. Let's suppose we want to test if capital A is uppercase. We use the AND operator. Notice I put a single ampersand to indicate the AND Boolean operator, and we do it one digit at a time. 0 and 0 is 0. And if you recall with AND, the way it works is 1 and 1 is 1, anything else is 0. So since we don't have anything here that is going to be 1 and 1, all of these are going to be set to 0, and there you go. So what we know here is that when we take the capital A and with the bit mask that we set up, we get 0. What happens if we try it with capital C? Well, that would look like this. It's still going to be 0. In fact, for any capital letter, it's going to be 0. Now what about for lowercase letters? Let's consider that we're looking at the lowercase a, the difference being this bit is turned on. So if we turn on this bit, now you'll see that 1 and 1 is 1, and the result is no longer 0. So for lowercase letters, we get not 1, but we get something other than 0. More specifically, we get what we are using as our bit mask. We get our bit mask. But another way of saying it is just simply non-zero. Now, that's in the case that we're checking an individual bit. If we were checking more than one bit, then it gets a little more complex, and we'll get into that later. But right now, what I want you to see is that when the third bit is off, the final result is 0. And when the third bit is on, the final result is not 0. And that's what we can use in order to create our function. So let's go ahead and do that. Let's write a program where we can check to see if a character is upper or lower case. Let's start with a basic program. And what we're going to do is we're going to have an if statement that is going to check whether or not the character is uppercase. Check if uppercase. And we'll have a different if statement for lowercase. Now let's go ahead and create a character. We'll create a character named our character, and we'll set it to lowercase c. Now how do we test if this is uppercase? Well, we're going to say our character and then we have to put in the binary value that we're testing for, which is this. Now for C, in order to express a binary value, you have to prefix it with 0b. This just tells C that we are using a binary number here. And then you don't have a space. So this is our bit mask. Now if we take our character and we AND it with this bit mask, we will get a 0 if it is uppercase. So let's go ahead and say that clearly. We'll put this in parentheses. and we will say is equal to 0. Now we know it is uppercase, so we'll go ahead and put a printf statement. This is uppercase. Now let's do the same thing for lowercase. We're going to still do an AND using our bitmask, but now we're going to be not testing if it's 0, but testing if it is in fact our bitmask. And if it is, we can print this is lowercase. And that's it. Now let's go ahead and run the program. And you see that it says this is lowercase. If I change it to an uppercase letter and we run the program again, you'll see that it says this is uppercase. Now let me go ahead and break down exactly what's happening inside of these parentheses. So first I'll go ahead and change this to a capital A to make it easier to understand. And now if I take this out of the if statement, just so we can break it down to understand better what's happening, let's do this. First of all, we don't need the 0b because we're going to convert this whole thing to binary so that we can look at the AND operation more closely. Our character is a capital A, which is the same thing as this. We go ahead and put it on 2 lines. And let's go ahead and move the ampersand over here just to make it a little easier to read. And what we have is the same exact operation we were conducting in our if statement, but now we're conducting it here. So 0 and 0 is 0, and we see that it all becomes 0. And that's exactly why this works. Now let's go ahead and reverse the process. This becomes 0. This becomes is equal to. This is our bitmask. We can go ahead and just put a 0b in front of it. And this is our character, which is the capital A. And of course we can change it to our character. Put it in parentheses just to make sure it's clearly defined. And there you go. There's our if statement again. I can just put it right in there. Now let's do the same thing for the lowercase letter. So we'll change this to a lowercase a. We're going to do the exact same thing. We're going to take this out of the if statement. Let's put it right here. Take out the 0b. Change this to a lowercase a, which is the same thing as this. Put it on 2 lines. Move the ampersand. And now we're going to conduct the same AND operation, 0 and 0 is 0, 0, 1, 0. And you notice that we get our bitmask. Now if we go ahead and reverse this entire process, this becomes is equal to, this becomes our bitmask, this becomes our bitmask, and this becomes our character. And you see that we have exactly what we started with. And we can go ahead and put this right back into our if statement. So hopefully now you should have an understanding of exactly how that works. Now the next thing we can do here is we can convert this binary number to hexadecimal. The reason being is that a long binary number is a little difficult to read. It's easy to get mixed up of where the 0 and the 1s are. So what we can do is convert it into hexadecimal, and the way we do that, well, here's our binary number. What is it in hexadecimal? This is going to be 2, this is going to be 0, so the answer is 2, 0. Now, in order to express that this is a hexadecimal number, we put 0x in front of it. Very similar to how we put 0b in front of a binary number. So let's go ahead and do that. We're going to change these two numbers to their hexadecimal equivalent, like so. Same exact program, it's going to function in the exact same way, only we have replaced the binary values with hexadecimal values, which is usually how you'll see it expressed. Now if we run this program, we're still testing to see if a lowercase a is lowercase or not, and you'll see this is lowercase, it still runs in exactly the same way. Okay, now let's go ahead and remove this uppercase code for right now and just look at the lowercase code. Now you notice here I have equals equals 0x20. Now I explained why that is because when you're doing the AND operation, you're going to basically get back your bit mask. But remember that inside of an if statement, anything that is not 0 evaluates as true. So this is equal to 0x20 is redundant. We don't need it. We know that we're going to get 0 if it is a capital letter, and so we can simply remove that and we'll be left with this. It's the same code. It still means the exact same thing that it meant before, only we have made it more compact. All we're doing here is we're saying if our character and 20 hexadecimal results in non-zero, then this is going to execute. Now let's suppose that we want to create a function for checking if a character is lowercase or not. To do that, let's decide on a return value. We'll say it's going to return an integer. We're going to call it is lowercase. And now as an argument it's going to take a character. We have to give that character a name. We'll call it test character. And then we can go ahead and write out our function. Now we want this function to return a 1 if the character is lowercase. Otherwise we want it to return a 0. So we'll go ahead and put our return 0 at the bottom of the function. And now we can go ahead and just move our if statement, because we've already written the code. We just need to remember that we're not calling it our character, we're calling it test character, so we can change that. And instead of printing anything, we're just going to return a 1. Now because of the way this function is written, it can do exactly one of two things. It's going to execute, it's going to check if the character is lowercase. If it is, it's going to return 1. Otherwise it's going to return 0. Now we can use that inside of our program like this. We can say if is lowercase, our character is equal to 1, meaning if it returns a 1, then we can print this is lowercase. Now again, like I showed you before, the equals 1 is redundant because if it evaluates to non-zero, that's sufficient. And so this will run just fine as is, except we still need to define our function. Let's do that real quick. We'll just put this at the very top of our program with a semicolon at the end. And now we have everything ready to go. So let's go ahead and run the program. And you'll see that it says this is lowercase. Now if we tried it on an uppercase letter, and you'll see that the printf statement doesn't run. Now there's a few things we can do to make this a little bit neater. We don't need a space here or here, and same thing here. And there you go. There we go. Now one more point that I want to make before ending this lesson is that this single ampersand should not be confused with this, which is 2 ampersands. So always remember that. They are not the same thing. This refers to the Boolean AND operation, which is very different from this. So keep that in mind, and that concludes this lesson.